there's a set of principles called the Toyota Production System that really makes manufacturing at Toyota pretty unique and highly scalable. And there's a lot of opportunities to introduce artificial intelligence into manufacturing. We're basically giving every manufacturing machine within Toyota the ability to have a human walk up to them and say, why are you broken and how do I fix you?
Wow. That's such a good use case. What is it? That if a machine breaks down, what's the alternative? Not having that solution in place.
So when one of these machines breaks down, each one of them has several manuals that are associated with it. And there are thousands of pages, if not, some of them are even tens of thousands of pages in length.
It's that typical kind of like long, arduous, intellectually complex manual labor that AI seems to have a sweet spot towards.
It takes hours sometimes to get a machine back up and running. And with some of the intelligence that we built, we changed that hours into literal seconds or minutes even, so that the machine isn't down as long and the manufacturing line isn't as bottlenecked.
I think at the moment, everyone's talking about, AI is going to take people's jobs and this, that, and the other, which, the data actually suggests that that's not the case. And jobs that are being replaced are ones that are already susceptible to automation without AI.
What we've seen is that we have a lot of users that are having their capabilities and their productivity amplified to a very high degree because they have these tools at their fingertips and they're able to get hours back in their day doing things they want to do, part of their job, instead of trying to fix things that are broken down.
I think the interesting thing about the robotic space, I suppose it's fairly similar to what we spend a lot of time talking about on the podcast. The following is a conversation with Kordel France, who is the principal AI engineer and AI architect at Toyotas. Now, what's interesting about this conversation, I had Kordel on the podcast in 2021, and he was at Seeker Technologies, voice AI startup, which successfully exited. And after completing his PhD in artificial intelligence, he then joined Toyota, worked on their voice assistant, in-vehicle voice assistant, and is now working at putting voice and AI into the machines on the factory floor, and also putting it into the hands of the mechanics in the service stations. And what's really interesting about this conversation is that we spend a lot of time talking about customer experience on this podcast and how AI is being applied in the call center, in the contact center. And don't get me wrong, the opportunity there is huge, and that's our bread and butter at VUX Consulting. However, not enough, I don't think, is spoken about what Kordel describes as giving machines a voice. And that's what this podcast is all about. How do you give an inanimate object a voice? In the factory floor, it's all about helping those machines understand what the problems are, predicting when they might be breaking down so they can be more useful at actually telling people on the factory floor, hey, I think I'm having an issue here based on previous issues that I've experienced. This is what might be happening. And when it does break down, or if it does break down, having a conversation with the machine to understand what's wrong and how do I fix it. This is saving hours upon hours for each individual factory worker. It's a great story of where AI and humans working together can bring real value to both the people in the business and the business holistically. So without further ado, here is Kordel France on VUX World. Kordel France, welcome back to VUX World, my friend.
Kenny, thanks for having me back. It's good to see you again.
Good to see you. Good to see you. It's funny because, as I was saying, we're always trying to find stories of people and companies that are doing interesting stuff and putting AI to work and making it work well and all this kind of stuff. And you come recommended by NLX. Andre recommended you. And he was like, oh, you should speak to Kordel. He works at Toho. He's doing some really great stuff. And I was thinking, I know someone called Kordel. I wonder if it's the same fella. And he sent me your LinkedIn. And I was like, oh my God, he was on the podcast not that long ago, really, 2021.
Yeah, it's crazy. I watched your combo with Andre, and I love NLX and what they do. And their product is, I really think they're making this distinguishing name for themselves in this crowded Gen AI space. And it was when I watched him on your podcast, I was like, wow, that's really cool. Like that intersection of worlds. It was awesome. So,
yeah. So last time we spoke, Kordel, it was, can you remember when it was?
I think August 2021.
Not quite. September 2021. 4 years almost to the day. since we last spoke on the VUX World podcast when you were at Seeker Technologies. We had a good discussion at that point. And Toyota now, what's been going on since we last spoke?
So when we last spoke, I was at Seeker and leading technology to merge voice capabilities with breath patterns in a medical sense. And since then, my founder and I had the fortunate opportunity of getting that acquired. We stayed on the company for a while, both exited. I went on to do a PhD and had a lot of fun with that, working on AI, machine learning, and robots, AI that learns continuously. And now I'm at an interesting opportunity at Toyota, leading the manufacturing development for artificial intelligence applications for manufacturing, and having a lot of fun doing some really interesting stuff there.
Nice. The only thing that perhaps was missed from the highlight reel, which I'm sure was at the top of the list originally, was the birth of your daughter as well. Congratulations on that.
Yeah, that's true. Yeah, I had a beautiful baby girl, and having fun training biological intelligence, having a break from training AI. And I thought those principles would transfer. Turns out not all of them transfer, but I used to joke with my wife. I'm like, I have a head start on being a parent because I've been training AI models for my whole life. So it's just biological intelligence, we'll move on. It's the natural segue. But yeah, I've had my work cut out for me, and she's teaching more. My daughter's teaching me more than I'm teaching her, I'm afraid.
Yeah. It's fun and it's life-changing, but it is also quite challenging, but rewarding at the same time.
I fully agree. Huge blessing, and it's been an eventful few years, as I understand it has for you, because the podcast has blown up, and it's crazy and incredibly cool to see where you've taken everything.
So tell us a bit more about Toyota then. So you said that you worked on their voice assistant for a while. Tell us a little bit about sort of what you're up to now.
Yeah, I worked on the in-vehicle voice assistant for a few years, and then transitioned to a role where I lead the AI development for a lot of the manufacturing applications. So there's, Toyota's, I'd argue its most impressive and incredible product is its production system, the machine that builds all the vehicles. The vehicles are great in itself, and that's what they're known for, but there's a set of principles called the Toyota production system that really makes manufacturing at Toyota pretty unique and highly scalable. And there's a lot of opportunities to introduce artificial intelligence into manufacturing. And so I lead a lot of those applications. And ironically, a lot of what we're doing, or a lot of what you see in the world right now, is how do we build AI applications that can allow humans to understand each other better? But how do we get something from the application? How do we get something from the AI and translate that back to the human? We're doing an interesting scenario at Toyota where we're trying to basically give all these machines a voice so that they can communicate a human. And so how do we extract enough information out of the human so that the machine understands? And so there are a variety of applications that we're using to improve the Toyota production system and improve manufacturing techniques, whether it be through Toyota's robots on their manufacturing line, or just general manufacturing machines that necessarily aren't robotic, but have a complex set of rules and computers on board, for which a lot of natural language processing or generative AI techniques can be used to help them communicate better with humans. So as an example, when a machine breaks down on a manufacturing line, it can cost any manufacturing company hundreds of thousands of dollars per hour or even more. And we're basically giving every manufacturing machine within Toyota the ability to have a human walk up to them and say, why are you broken and how do I fix you? By allowing this machine to access its own data, access its previous history, access its own machine learning or its machine manuals, and basically say, I think my hydraulic fluid level's low. Actually, these processes, all these mistakes I've been seeing are based on a bad tool head that needs to be changed, or the robot needs to be re-zeroed and recalibrated. Instead of a human trying to figure out all these things and spending hours trying to understand why these complex machines break, we give those machines the ability to communicate and say, this is how I'm broken. This is what you need to fix me.
Wow. That's such a good use case. I'm curious to get into that in a bit more detail, because I suppose the alternative, I'm just trying to think about the current sort of way that things may be. Is it that, what is it, that if a machine breaks down, what's the alternative? Not having that solution in play, what's the existing way of debugging it and figuring out what's going on?
So when one of these machines breaks down, each one of them has several manuals that are associated with it, and there are thousands of pages, if not some of them are even tens of thousands of pages in length. And so to have a human go through that and try to figure out what's broken can be pretty daunting, right? And pretty agonizing, especially if these don't even have a PDF form, I mean, some of them do. Some of the older ones don't, though. They're actual books. Toyota has a pretty good maintenance standard, so even older machines are still running quite well. So those might not have a digital form for which we can access. But regardless, it takes hours sometimes to get a machine back up and running. And with some of the intelligence that we built, we changed that hours into literal seconds or minutes even, so that the machine isn't down as long and the manufacturing line isn't as bottlenecked. So we're really providing some more automation. Instead of a machine breaking down and the line stopping, we can even start predicting when the machine will break and start having it raise its hand saying, hey, I think something's about to occur. Just letting you know, maybe watch me for the next little bit because I might need a tool head changed out, or I might have a hydraulic leak or something because I'm noticing irregular hydraulic fluid moving between lines. So you sort of build this intelligent system that can not only just say, hey, look at this data and find a needle in a haystack, but can actually communicate it back into natural language to technicians. There is a further problem that kind of exacerbates this, in that nearly a third of engineers at Toyota's manufacturing plants all have less than 5 years of experience. And so if you have someone that's worked at these plants for a very long time, that knows these machines well, maybe they can troubleshoot them quite quickly. But when you have students coming out of college or out of trade schools that don't necessarily have all this legacy knowledge, they might not understand how to fix the most common or even the most simple problems on these very elaborate machines. And they're very complex. They're not just simple drill presses. They're very, very complex machines, oftentimes built in other countries than the US with different language standards and things. So being able to break things down into clear steps of what somebody new to the trade should do in order to fix a machine is also something critical that we built in to our AI as well.
That's such a good idea. The fact that it was taken, manuals in books that take forever to get through is a great place to start. It's that typical kind of like long, arduous, intellectually complex manual labor that AI seems to have a sweet spot towards kind of solving or contributing to. If you are based in the UK or in and around London, and you are interested in a little get-together that we are putting together, then you should join us on the 11th of September for the Conversational AI Meetup. It's in partnership with Lloyds Banking Group, one of our long-term clients at VUX Consulting, and we'll be discussing our chatbots, the new app. And we'll be hearing from Lloyds Banking Group about how they've been experimenting with generative AI and what the future of banking might look like. We're going to hear from Labara, Chris Miles, product owner over there at Labara, large telco, discussing the experimentations that they've been doing with Gen AI and the most recent production assistant that's just gone live over there, lessons learned and all that kind of stuff. I'll be sharing one or two little nuggets myself as well. There'll be plenty of food, plenty of drink, plenty of networking opportunities. We've got nearly 100 people signed up so far who will be joining us in London. All the details for this meetup, if you are interested in joining us, is at vux.la/meetup. That's vux.la/meetup. Come join us there. But I'm curious about the part in which, because I think most people listening to this would probably understand that you could take those manuals, probably, I don't know how you get them to be digitized, but you could always take a photo of them in a simple sense, transcribe them. Now you've got documents of the, the books have been digitized, so to speak. You could, vectorize all of that stuff, stick it in a RAG sort of setup, and then you can search for stuff. And I think that a lot of people listening would understand that would be one way in which you could get that data into a place where you could search it. I don't know if that's what you did or not, but I think the gap from getting to that point to the machine being able to take its own fault codes, combine that with the search, then deduce what the issue is, and then produce a response seems to be another layer of complexity that I think most that have just gone and looked at RAG, for example, probably haven't come across. So I don't know if that's how it's working, but I don't know if you can share a little bit more in terms of like how that stuff, how all hangs together and comes about.
Yeah, so RAG is a huge component of what we use. There's a lot more on top of that, but RAG is a pretty fundamental mechanism. So being able to take all this data and put it into a vectorized format in a common embedding space, so that the generative AI model can search through it, is crucial to making a lot of this happen. We have a lot of multilingual users as well, and so we have to be able to handle maybe a lot of this data might be in English, right? But we might have the same machine in Japan, and so we have to be able to handle the translation between Japanese to English. And there are a few things that we found, like there's always a translation loss. So if you ask the same question in Japanese that you do in English, you should get the same answer, but with certain embeddings models and certain techniques, you do not. And so there's a lot of extra stuff. There's that extra 10%, that last mile completion that you have to do in order to get pretty reliable results. And then in addition, how do we interface a cold storage RAG database that maybe has a bunch of manuals, a bunch of other data that isn't necessarily going to change over time, with real-time operating data from that machine? So if a machine breaks down, there's obviously probably a series of processes one can go through in order to get that machine back up and running that you might pull from the cold storage RAG data. But there's also live data that's associated with that, from which you need to contextualize both the cold storage and the live data. So you need to pull what have the last 60 hours or last 100 hours of that machine's runtime look like? Have there been any deviations in comparison to the last 1,000 hours? If there have, where have those deviations been, and how do we contextualize that with what the last breakdowns were? Is this a repeated breakdown from last time, or is this something entirely new? If it's a repeated breakdown, this might be a heuristic for us to go back and just use some sort of agentic mechanism to look through the previous breakdowns. What were the solutions? Let's look at that and see if we can just replace that part. If it wasn't a breakdown that we've seen previously, then it's something else. And then we've got to do a bigger search, and we've got to do something a little more elaborate. And so instead of these one-shot requests where we're just kind of looking things up in a RAG database, we're sort of building this continuously monitoring, fault-tolerant and fault forecasting mechanism that is always running and always going to be able to predict what might happen on any given machine, and relay that back to the user, so that instead of something breaking down, that in breaking down breaks 3 or 4 more parts within the machine, we can forecast when that's about to happen so that we can stop the machine, replace maybe a simple ball bearing, or just lubricate something a little bit better, or replace a tool head before we have to replace an entire crankshaft or gear shaft, series of planetary gears, or something like that. That's going to cost a lot more time and money.
That's really good. And so it sounds to me as though you must have some sort of more traditional machine learning stuff running here. Would I be understanding that correctly?
Yeah, it's a confluence of modern agentic and generative techniques with, I wouldn't even say classical machine learning. I know that has a different meaning now than it did. Classical machine learning was like what was done in the 80s when I went to school. And now classical machine learning, I've heard it referred to me as like what was done before ChatGPT.
Yeah.
And so I guess machine learning techniques used before ChatGPT, we use quite a bit as well. So it's this beautiful confluence of both techniques working together to produce a series of unified results on what one should do about any given machine at any given time.
Yeah, that's good. Because I think that's where, the pre-ChatGPT machine learning, I think it almost like has been sort of discarded a bit now. But the reality is that most organizations that are running AI are running, whether you want to call it traditional machine learning or not, it's besides the point, but it's not generative. So, for example, you go to Netflix, and every time you open up the Netflix, app, you're seeing the result of some algorithm that has predicted what might be of interest to you down to the thumbnail that it's showing you. And so that kind of like the greatness of machine learning in its ability to find patterns in data and to surface those patterns is something that, why try and reinvent the wheel type of thing? But I just feel as though it's a little bit, I don't know, lost in the hype now, I think, that kind of stuff. Whereas, it takes that stuff in combination with the more contemporary generative AI to holistically make something work.
Yeah, you've hit on a problem that I'm very passionate about. There was a lot of really good research and a lot of good work being done on general machine learning techniques before the advent of LLMs. And I feel like a lot of that has been lost, especially with there was a lot of great work on explainability techniques with just even like 2 or 3 layer neural networks. And we don't even understand how those work to 100%, let alone how these, 1,000 layer, trillion parameter LLMs work. So yeah, explainability, I feel like there could be a lot more work done. But to your point, there's still a huge place, in my opinion, for regular machine learning. You don't necessarily want to always kill a spider with a shotgun, right? Maybe a fly swatter or a simple shoe will do, right? So you can use the right tool for the job, and there are certain tools like recurrent neural networks, LSTMs. Those still have a place, right? General principal component analysis, TSNE analysis. These fundamental machine learning techniques can still be used quite well to get extremely fast and still reliable answers, I'd argue. Because if you need to get something done, or if you need to solve a problem that a simple 2-layer transformer or 2-layer RNN can do, why would you send a request to Chat GPT or any other large language model, to Azure, to Google, to AWS, in order to get a response? When you get into the corporate world, that becomes extremely difficult, right? You can't just make a request to clouds because they have to be sanctioned. You don't know what they're doing with your data. And so the more you can do on board at the edge, the more lift you get, the more you can appeal to cybersecurity, the faster you run, the more reliable, the more conservative you are with resources. So there's a huge advantage still to use primitive machine learning techniques in order to get a lot of jobs that need to be done today. And I hope that's not lost. It was someone younger told me the other day that training machine learning models is dead and it's going to be a lost art. And I really hope that's not the case, because the argument they made is anyone that's going to be able to train a machine learning model is going to need massive amount of money and compute. And the only people that can do that are very large research institutions or very large companies that have the money to. And the ability to train an LLM or anything is going to not be feasible in the future, and it's just not. And RNNs and all these other things are not going to be applicable. And I hope I don't think that's the case, and I hope that's not the case, because that would be just a dark future in my opinion.
Yeah, it's a little bit like, the whole kind of sledgehammer to crack a nut type of thing, or a shotgun to kill a spider, which is like, I don't know. I asked this question. Well, it was a while ago now. It was a few months ago. I give a talk at an event, and the point of it was that I was saying that the underutilized technology at the moment is small language models, because everyone's just running and grabbing GPT-4, GPT-5, whatever the latest model is, and it's kind of like that's what's seen to be the model that you need to use. And obviously, the capability of those models is getting better. The cost of running those models is getting smaller. And so, you could see a world in which, as the capability grows and the cost comes down, the counter argument to the whole small language model thing is, why would you ever bother with fine tuning a small language model when the capability is inherently going to be in the bigger model, and it's going to be cheaper over time to just use that? And I can kind of see that, and I can understand that logic. I just don't know whether that's the reality of how it will play out. Like a small language, for example, I don't know exactly how you're kind of running things over there, but let's say, for example, that a small language model fine-tuned on the specific data of one specific machine, in theory, might outperform a large model that's more generic, that hasn't been tailored to your use cases, etc. And in that case, you could freeze it in time. You could run it on your own servers, very cost effective. It doesn't suffer from catastrophic forgetting or model drift or any of those kind of things. But again, the question is, like, is that the reality? Because will it be that those big models are going to be so cost effective and so capable that small language models are no longer needed, and traditional machine learning techniques are no longer needed because it's all possible with these monolithic models? I don't know.
Yeah, it's a good point. There's a strong argument that can be made for LLMs, right? They're cost effective, and I mean, if it takes tenths of a penny to just send a request and get a response back, why would you spend the time training a smaller model in order to try to get similar performance? The way I'm kind of thinking of it is I see LLMs as just giant computers, right? We make a request to them, they're virtual machines, and we make a request to them and we get a response back. Why would you build your own computer if I can just go to Apple or Microsoft or NVIDIA and buy my own and have everything I need right there? It's all ready to go. I don't have to build an OS. I don't have to get the hardware. But in following that analogy, there's still a place for like microcontrollers. My microwave doesn't need an operating system. It doesn't need a full computer to run, or a coffee maker, or even this microphone, right? They just need very small primitive electronics to run. And so while the cost of computers and building an operating system and adding, a GUI and everything have gone down over the years, there's still a place for these smaller, less capable computers and things. And that's kind of the analogy I'm drawing to these, I guess, smaller classical machine learning models and large language models. You touched on small language models, right? Which I guess to me would be something around the size of like GPT-2 or BERT. And there's a lot of lift I feel like can still be can still be gathered from those. I can run GPT-2 now on my laptop and fully train it. In fact, I've been experimenting with it quite a bit the other day, just because it's almost an LLM, but it's actually tractable for me to train locally, or on a virtual machine without jacking up costs. And I mean, it's pretty capable as a model, as for very small tasks. And I think there's still going to be a place for these smaller models in the future as a result, just because you might not always need the sledgehammer to crack the nut, if you will.
Yeah. For the record, I actually agree with that. I think that big models will, well, actually, whether they will become increasingly capable, I suppose, is up for debate, because if you look at GPT-4o compared to GPT-5, there isn't a huge difference in terms of what it can do. Like that is definitely an incremental release than it is a transformative one. So who knows, GPT-6 or 5.5 or whatever it might be might just be another incremental jump. And I suppose 20 years of incremental improvements would be great. But I think that if you're going to design a solution today, you spoke earlier about kind of Toyota and how Toyota's known for its lean manufacturing. It's known for things like its hypothesis testing, its A3 templates. It's contributed greatly to practices that can be used outside of manufacturing in software development and things like that. And I suppose in that context, going to the lean production kind of framework, you want to have the best possible concoction of technology available at any point in a process to make that point in that process deliver as much value as quickly as possible. And obviously that doesn't want to come with its own bloat and its own, inherent astronomical costs and all that kind of stuff. So as a business, in the same way, it sounds as though you've done with the robots on the factory floor, you've got a solution you want to create. You know that it's going to require components to build it, and you want to have the best component running at each part of the process to make the whole thing as best as it can be. I don't necessarily think that approach will disappear as models get better. I think I agree with you. I think that traditional machine learning has got a role to play. I suspect small language models have got a role to play. Obviously, large language models definitely have got a role to play. But I think that the best solutions over the next, foreseeable future for me are going to be ones that are blending the best tool for the job.
I fully agree, 100%. And I see that especially with robotics, because a lot of robotics projects are constrained to edge processing. So you can't make a lot of requests to the cloud. Now, there's some really great work going on to quantize and compress large vision language models into something that can fit onto more edge electronics. But we're encountering a point where, up to a couple of years ago, robots weren't really good at taking commands. Like we had Alexa and some other voice assistants, but robots were basically deployed and they were following a set of instructions, and they had to get like basically computer formatted instructions in order to do something. But now we're at the point where we can give robots actual English commands or Japanese or German or French commands or whatever, and actually get an intelligible response out of them. And so as robots become more capable in processing, they're never going to be at the level as these large language models. And that definition is going to continue to move throughout time. I mean, a few years ago, I think BERT and GPT-2 were large language models, and now they're like small language models. And so that definition is going to continue to move. But edge processing is going to get bigger and better, but it's over time, and we're going to be able to process more and more of these vision language models on the actual robot itself to interpret English commands or interpret actual natural language commands. And that's actually a pretty interesting inflection point, I feel like, in the timeline or the arc development of AI and robotics intersecting, because we really have this like this intersection of human and robots together that are going to kind of, I feel like, build a merged path versus like AI developments in one domain, you know, and robotic developments one domain. But now they're kind of merging together with humans. And there's a term in Toyota that they call jidoka, which is automation with a human touch. And that's a Japanese term, but it really exemplifies what I feel like is happening right now in the space. With the advancement of natural language processing, we're seeing this jidoka principle being realized with robotics, because we're able to give them and more empathize with them due to the way that we can interact with them. So I think all this to say, it really complements what you're saying. As processing gets better and better, I think it's going to complement the robotic space quite well too.
Yeah, I think the interesting thing about the robotic space, I suppose it's fairly similar to what we spend a lot of time talking about on the podcast in terms of like the customer experience space, is that, you know, regardless of the robot, in your case, let's take the one on the factory floor, the conversations or the requirements of that thing are fairly narrow, aren't they? You're not going to walk up to a machine and be like, hey, you know, what's the weather and get me a recipe for mac and cheese. You know, it's going to be about what's the issue, how do I fix it, or whatever it might be. So you're constrained in terms of the domain. And the same thing in customer experience in lots of other areas is that I think where AI, and this has always been the case, even when we spoke in 2021 and even before that, when we first started the podcast, I remember having conversations with people like Jeff Smith Jr. and others who were basically of the mindset that constraining the problem and solving that one problem at a deep level is where AI will flourish. And I think what LLMs have done is they've brought us the general purpose technologies, which are very tempting. And I think that's where people think that they can do everything because they are more general purpose. But still, if you want to solve a very specific problem, like, you know, put a robot on the factory floor that can do X, Y, and Z, you still need to have that deep expertise, don't you? So I think it's interesting how that, as you were saying, the AI development plus the robotics development converging, because that will be crucial for the next stage. I think at the moment everyone's talking about, you know, AI is going to take people's jobs and this, that, and the other, which the data actually suggests that that's not the case, and the jobs that are being replaced are ones that are already susceptible to automation without AI. So I don't think there's necessarily kind of parallels to be drawn there. But the case still is the case is that for AI to become ultimately most useful, embodying it in some way, shape, or form is generally the direction that it will get to, because otherwise an AI can't get out of its screen to actually do anything, you know. I don't know if you subscribe to that.
100%. There are two camps of thought that I've been able to find, or at least two camps of thought within the AI space. One is that you can, because the entire world can be described by language, all the intelligence needed to build artificial general intelligence can be done through just language. I don't necessarily subscribe to that. I'm more of the camp that follows that you need real world interaction and embodied experience to actually acquire intelligence, multimodal, multisensory experience, walking throughout the world, moving throughout the world, understanding cause and effect in order to have, super intelligence. And so, I agree with you. We have kind of these generalist agents that are being released by these large companies that can do a variety of things. But at Toyota, we have to very significantly descope that. If we don't have a closed model, if we have an open model, pruning is a huge thing that we have to do in order to get a very specific scope of tasks from a generalized model. I don't need the manufacturing robot to tell me how to bake banana bread. I don't need it to tell me or give me directions to the nearest Starbucks. I need it to to do its job and to fix itself and to spot, indicators of potential failure in the future. And so, yeah, it'll be really interesting to see like how do we build these specialized models from these very generalized models in the future? Is pruning enough, or does it, is fine tuning enough? What does that look like, and how does that actually manifest into robots? I think we see a lot of these humanoid companies coming out, these humanoid robot companies that all have this natural language interface with them, and they're going to be generalized to start, probably doing like general household tasks or just a general. Yeah, I think general household tasks is what most companies are advertising. But over time, they're going to grow to be very specific, right? This is a construction robot. This is an agriculture robot. This is a manufacturing robot, and they'll grow into that specialization that humans embody. My cooking skills, I don't have any, but if I did, they wouldn't help me in my job at Toyota or as an AI researcher. But they would help me if I was a chef. However, I'm not a chef, so maybe I don't need to focus on my cooking skills. So all that to say, like the specialization that we see in humans, I think are going to translate quite well to embodied AI in the future.
Yeah, I can see that. I can see that for sure. The only I think that the place where that begins is in, you mentioned the in-home kind of robots. I think that the big models, it's the same as Alexa. I think the whole thing will play out again. I think the whole Alexa thing will play out again, which is that the first in-home robot will be a general purpose thing. And it'll do generally, tidying and washing up and all that kind of, all that generalized stuff. But I think for it to be actually useful in the real world, as you say, it needs to specialize in a specific task. This one builds walls, and it builds walls very well. This one, is builds things with wood, creates frames for a house, for example, whatever it might be. I don't know, but it's I think that's definitely the case. I think the whole thing you were talking about there in terms of like pruning of these models to de-scope them is a very interesting area, because it's essentially what we've been talking about, which is that the power of the models are great, but they're big generalized models, and therefore they may be good at the task you want them to do, but the risk there is that they end up doing things that you don't want them to do because that's not part of the scope. Have you come across any challenges or concerns or any hurdles you've had to get over when you've been looking at implementing this stuff into an actual thing, like into a robot that's doing an actual physical job? Now you've got an LLM running inside it partially. Like, have you uncovered any challenges that you think might be worth sharing?
Yes, there are a lot. So one of the first examples is a lot of the closed models that we have to use, or whether it's closed or open, it doesn't really matter because the same principle applies. But we try to provide as many guardrails as possible to make sure that the actual task that needs to be performed by the end user is the only thing it can do. However, in battery manufacturing, we had some AI deployed, and the users were asking questions, and the language of that battery manufacturing domain, of battery chemistry domain, had a lot of the same language that was in pulmonary biology, I guess, for healthcare. And they were talking about dendrites and anodes and cathodes and electrolyte imbalance and how copper and zinc influence different imbalances in the electrolyte and anode. Anyway, they were getting responses back from the LLM that had to do with fixing something with the lungs in a medical setting. And it was convincing enough that if you didn't have enough knowledge of chemistry, or battery chemistry, you might accept it and move on. But because we have some engineers that looked at that and they go, this is BS, this is not right, they were able to spot it right away and flag it with us. And we had to implement some pretty interesting guardrails to make sure that we aren't, searching improper, like that didn't come from our data. That came from something, the bot's internal knowledge, or it came from the internet. And so we have to scope the tools that the bot has access to. We have to scope significantly the internet, or the internal knowledge of the bot. And so there are all these pockets of knowledge that these LLMs know that aren't helpful and contributing. And it's very difficult to shut those off sometimes. Even if you prompt tune the hell out of it, it can still be difficult to try to isolate the exact knowledge that you want the LLM to implement. So with a human, that's not necessarily a problem, because you might have, for example, I might have cooking skills that can sharpen my problem-solving abilities in artificial intelligence engineering, and I'm not necessarily using cooking skills to improve how I solve problems, but the problem solvings that I acquire through cooking are advancing my problem solving through different domains. And so I'm curious on how that's going to actually manifest in LLMs or AI in the future. Is we have these generalized agents. We know that solving generalized problems help more specific problem solving, but how do we, after they're trained, turn off the specific knowledge attributed to that generalization in order to get specialized agents that only can focus on the task at hand?
That is a very, very good question. Yeah, that's a very good question. I think the where we are now is essentially having to just prompt the hell out of these models, which isn't helpful at all, because it's like you want that generalized approach, don't you? So in your case, where it's getting two types of chemistry conflated, one's biology, one's battery science, you could fix that perhaps through some very intense prompt engineering. But then what happens when you come across another scenario that you hadn't thought about because it hasn't occurred, but it does the same thing later on because it's conflating two concepts that you hadn't thought about putting in the prompt. Now you need to put in the prompt again, and now you need to test it again. How do you test for something that is it's not an emerging behavior, that's the wrong way of thinking about it, but there is scope within your application that you are unaware of because it's not feasible to touch every single side of the problem, because the whole point of these generative models is that they can be used for a variety of things, and you can't script every single conversation that you have with them. So it's kind of like, yeah, I think solving that through prompting doesn't seem to be the solution for me.
I agree. We tried looking at tuning the embedding space to try to get rid of that problem, right? So all these LLMs, they communicate, they turn words into numbers through vectorization via an embeddings model. And the embeddings model you use can tell how those words are placed next to each other or how similar certain words are. So for example, if I have France, England, and croissants in one embeddings model, England and France might be close together because those are geographic locations. And another embeddings model, croissant and France might be close together because those both have to do with France, right? And when you use a different embeddings model, you strengthen certain relationships, but then you break others. And so when we train embeddings model on manufacturing specific data or Toyota production system specific data, we're not only strengthening relationships on manufacturing related terms, but we're breaking relationships elsewhere. And the ability to monitor that comes down to how you establish like golden queries, which is a known practice, and how you calibrate the model after it's been built and trained. But there's still a lot of opportunity to optimize that process. How do you do not catastrophic forgetting? That's a whole other problem. But how do you do like specific forgetting? How do I take this domain knowledge out? How do I take everything related to the thing I don't need out? You almost need like this. It's not even pruning at this point. It's almost like LLM surgery to take out the chunks of the brain that you don't need. LLM lobotomy, if you will.
Yeah, that's interesting. It's I mean, is there any tools out there for this kind of stuff, or is it all done at the moment through a combination of embeddings and prompting?
There are tools out there, yeah. And I think there's some evolving standards on what to do. Like obviously there's pruning. There are a bunch of tools that you can use for explainability. With closed source models, it's a little bit difficult because you sort of have to rely on prompting a lot. But if you have an open source model, you can dive in and do a little bit more surgery than you can with an open source model or with a closed source model. So I feel like the most opportunities that are going to, or the most advancement in the state of the art for explainability are going to come through open source models. And there's a lot of great work being done, but I don't know of a specific standard yet that's been developed. Like you do this, this, and this if this happens, especially as these models get more and more complex. They're all mixtures of experts, or most of them, I think, are mixtures of experts at this point. So do you turn off a specific expert? That would be great. Do you delete certain data from the specific expert? Like what level of granularity do we need to go in order to delete certain facets of knowledge? I think those sort of principles and those sort of standards are going to manifest over the next few years in order for us to get these types of specialized models from generalists.
That's very interesting. I suppose then there's a whole new round of testing that needs to be considered, isn't there? Because if you're if you want to take away knowledge, in your case, you want to take away knowledge around biology, keeping knowledge about battery science. But then, as we were discussing, perhaps there are learnings regarding generalized principles that you might want to keep, that you might lose when you remove certain bits of knowledge that you probably aren't aware of, because you're just removing what you think is the knowledge rather than any inherent understanding around any principles or process or any of that other stuff that might come with it. So presumably, it seems to me, at least in my inferior knowledge of this level of detail, it seems as though testing is crucial.
I agree, 100% agree. And especially with embodied AI, right? Now we don't just have things that are giving maybe inaccurate text responses, but as we move forward with robotics, and embodied artificial intelligence, we're going to start getting things that can do perhaps the wrong actions, which might have more effects than just saying the wrong thing back in a chat. So, and maybe just to be clear, maybe the answer isn't forgetting the knowledge, because I don't think anyone, that may have done a career change in their life, maybe they went from a chef to an AI engineer, just to continue to play the analogy. I don't think anyone would want to lobotomize the part of their brain that's attributed to chef skills, right? They'd probably want to keep that. That might help them in different things down the road. So there's a path to being able to leverage the generalized knowledge into specific knowledge, maybe without deleting certain parts of the machine learning model. But it feels like that's what I'm doing when I'm prompt tuning an LLM to say, don't discuss this, take this out. If the user asks this, don't do this. Or when I'm pruning a neural network, like it feels like I'm almost giving it them a lobotomy. And I want to see if there's a better way to do that so that we can use those generalized skill sets just in the appropriate manner.
Yeah. And even so, it's like, just because it's in a prompt that says don't do this and don't do that and don't talk about this, and if the user talks about this, then they actually mean that and not the other. Like, this is where you end up with prompts that are like 2,000 words long, and then you're in a situation of being like, well, how do I know whether every line in this prompt is actually being followed?
Exactly. I fully agree.
It's a real challenge, because then it's basically the quest for control leads you into ever more elaborate prompts without any way of really doing any kind of regression testing on it, or any kind of any understanding whether it's actually doing the things that you want. What I've mentioned this a number of times, I've seen countless occasions where a mile-long prompt has repeated information throughout in capital letters and asterisks and all that kind of stuff, because it's like, pay attention to this bit here. At the expense of what? That means don't pay attention to some other bits. And we know there's research out there that's seen that in a long prompt, the model will pay more attention to the beginning and the end and a little bit of the middle, and outside of that gets a bit more lost. So it's kind of like, how effective is that level of prompt engineering? I'm on the fence about it, me.
Yeah, I fully agree, because then if you have to repeat certain things and you have this long prompt, then your context window blows up, and then you have less that you can attribute to the question. And yeah, there's a lot of opportunity for optimization there. And I don't think the current autoregressive form of LLMs are the end all be all to what we will need in the future, but we're in the right direction. But I'm curious to see if getting to the North Star that you and I are talking about is going to be a consequence of just some minor enhancements on the current architectures, or if we're going to need something completely different. And, there'll be the Transformer 2.0, or there will be some sort of radical new architecture that can, continuously learn and do all these things versus what we have now. I'm not sure. It'll be really interesting over the next few years to see.
Yeah, it definitely will be. I mean, again, I suppose I'm fortunate in a way, which is that I really don't have a horse in the race, and I'm just curious about what's going on and who's doing what and where and how it's all unfolding and stuff like that. There's some stuff we do on the consultancy, which I suppose is a bit more opinionated, but broadly speaking, it doesn't really make a difference to me. I'm just genuinely curious. I suppose you've got those that are absolutely all in on LLMs. Then you've got those that are absolutely not all in whatsoever. The Jan LeCuns and Gary Marcuses of the world, which are like, the foundational technology here is there's an issue with, and so it's not going to get to where we need it to get to. There's lots of stuff around, symbolic AI, which I've done a couple of episodes on in the past, which sounds quite interesting. Lots of people who are really favoring combining different types of AI with knowledge graphs and having the knowledge graph as the sort of like underlying, not source of truth as such, but having the knowledge graph play a role in getting rid of some of the issues that we've spoke about. There's a company called IGO, which are quite interesting. They have this sort of like, I forget what they call it now, but it's a totally different approach, totally different architecture. It's all about kind of like an artificial intelligence should be able to learn from novel experiences that it hasn't come across before. And obviously LLMs have to have come across whatever it is before, because everything they generate is from their training data, which they see as a limitation. So there's lots of other alternatives, but I don't necessarily think it's one or the other anyway. I think what we kind of get into in this conversation, I think, is that the future of useful applications is being able to select the right type of AI or the right type of technology for the right type of problem. So if anything, I think maybe we'll get to generative AI reaches a point where it's understood what it's good for. Maybe symbolic AI goes through the hype cycle next, or knowledge graphs goes through the hype cycle next, or whatever it might be. I think we'll arrive at a place where we have loads of different types of technologies that we can leverage to do whatever we need it to do.
I fully agree. And I do like some of the tools that are coming out. These current LLMs are good at generating things and generating lots of text, lots of images, whatever data modality you want. But there is the consequence of hallucination, and we've found that sometimes in the things that we're building at Toyota, we get the right answer, but it would have been helpful to be more specific. And so what I like about some of these tools, NLX being one of them, right, is that you have the ability to get deterministic outcomes from these non-deterministic LLMs. And so if I know that this bot or this AI is supposed to fix this manufacturing machine and find out why the problem of a for example, of why this robot is not going to the same place every time, it's picking up things at different locations. I'm going to continuously drill into that until I find a few key aspects of that problem. And tools like NLX allow us to do that, because we're not going to stop analysis until we get to those specific components that are related to the problem. I think prior to LLMs, it was called slot filling. I don't know. It seems like that's kind of a term that isn't used as much anymore, because every time I say it, people give me a weird look. But it was a very prudent topic back in like 2020, 2021. But I know NLX does more than that, but that's some of the appreciation I have for their product, is because we get these deterministic outcomes from these non-deterministic LLMs, which is funny because LLMs were specifically built to get to give non-deterministic outcomes, as I understand. And now some of the complaints is that they don't give deterministic outcomes. So to tie all this back to your point about symbolic AI and to some of these more like fundamental principles, I think it's going to be a confluence of these non-deterministic LLMs to these deterministic outcomes, these fundamental principles that have been around for a while. And in order to get the outcomes that we need as humans, as well as super intelligence, we're going to have to blend everything together.
Yeah, agreed. It's interesting because you talk about LLMs and the flexibility of LLMs and how they can deal with unpredictability and manage conversations and stuff like that. But then if you look at the architecture of a lot of these platforms, not NLX, but others, when you have a look at what they're doing, they have prompts that just go around in a loop. And that loop is basically, this is the context of the conversation. Here's what to do next. Okay, go and do that next thing and put the guardrails around it. Make sure it all makes sense, all that kind of stuff. Then go back and now, okay, here's now the context of the conversation, and now go around and do it again. And so what ends up happening is, when you look at the architecture of some of these agentic bots, as they're often termed, they are sometimes, I don't want to underplay it, but sometimes it is glorified slot filling. Because the LLM's just going round in circles until it's got the information it needs, and then it's populated the slots it wants, and then it moves on. You know what I mean? It's crazy how, yeah. I mean, it does it more effectively. It does it with more dynamism and a lot more natural, free flowing conversation. But the essence of what it's doing is slot filling. If you need to change your address, and you've moved house and you need to let your utility company know that you've moved. That utility company needs to have some very specific information from you, where you're moving from, where you're moving to, what your reference number is, whatever it might be. And that process of getting that information, it is basically slot filling. There's no other way of dressing it up.
Yeah, it's like a regular expression mechanism, right? But yeah, we can do that now with LLMs and I guess a lot more compute in order to accomplish the same thing. So the thing is, you don't have to build a regular expression. You just have to prompt tune the LLM to get the address, on all the slots that need to be filled. But yeah, it's interesting. Some of these things have come full circle, some of these problems. And so it's interesting to see some of the things that I feel like are being repeated. Some of the solutions that are being built that I feel like maybe solutions already existed, but it was before LLM days, so maybe they're not quite as sexy. And some of the solutions that are being addressed that we could never solve before because LLMs are just so good. So yeah, it's the future will be interesting. There's going to be I don't think there's going to be one winner in one winning principle, one winning mechanism, one winning algorithm. There's going to be this confluence of several things that just manifest these really impressive applications, especially in manufacturing, just because it's such a dynamic environment. And we see that even off the shelf tools that we have to take are not as ready as they're advertised. There's a lot of customization that has to be done in order to address the dynamism in manufacturing and all the different users that we have to accommodate. So yeah, I think there's a lot of opportunity for progress, and I'm excited to see where that goes.
Nice. Well, I know we're at one time. Are you good for time? But I've got two final questions. Have you got 2 minutes?
Oh yeah, I've got all the time you need.
Okay, cool. So I'm definitely curious about how you're using NLX. Is NLX used within the stuff we've discussed so far, or that's a separate solution?
So yeah, I can't go into a whole lot of detail with the specific vendors, but for NLX, we use them for a lot of our dealer-based applications. So when you bring your vehicle into a service garage at Toyota to get the oil change or get a general fix, there's a series of processes that the technician goes through in order to check everything. And a lot of times, these technicians have to remember. They get judged by how many they service per day or per hour, and we have to get faster or we have to get more efficient. And vehicles are only getting more complex. So especially as you have different powertrains, different engines, right? We don't just have gas engines. We don't just have electric engines. We've got hybrid gas electric engines. There's even Toyota fuel cell cars, right? So we've got all these different powertrains that need to be analyzed and troubleshot. And all these different fault codes, they have more and more software associated with them. So the cognitive load on a technician is getting bigger and bigger every year. And so there's a lot that AI can do to help augment their capabilities. And NLX is a part of that effort. So for example, if we have a technician that is underneath a Toyota Tundra and trying to change trying to understand what's going wrong with an ECU, and they don't necessarily want to crawl back from under there, take off their gloves, go type into a computer, do a control find through this giant manual to figure out what needs to happen with this ECU on the Toyota Tundra. What if we could just ask an AI to describe the problem to them, and in real time they can look it up and they can answer immediately and say, oh, by the way, this has been several issues throughout all the Pacific Northwest region throughout the last 3 months on this type of model. Maybe it's a common issue. Maybe we should zoom into this. Does this seem to be analogous to your problem? So having this like co-pilot that can help you service vehicles faster and just get more throughput through our dealerships is what NLX is particularly helping with.
Oh, nice. That sounds good. So what's the interface there then? Is this like an earpiece that the mechanics have? Is it done through their phone? Is it through the car? Like how do they access this thing?
Currently, it's a GUI through a laptop, transition to mobile, and then the ultimate end goal is to have a voice interface so that it can be asked in a variety of scenarios. Technician doesn't have to take off any gloves. It can just all be audible.
Yeah, that's ideal. That's another kind of unique use case. I think it might have been Rain Agency a long time ago. They were a company that specialised in like Alexa skills and stuff like that. Pretty sure they got some funding to try and do something like this, where they were working like with like in-car technicians trying to solve a similar sort of problem. But it's an interesting area. It's an area that is, again, not the typical call center automation. Call this number and speak to a voice bot. It's more. I don't know whether imaginative is the right word to use, but it's definitely focused on solving a good pain point. Comes with its own complexities, I would imagine, in terms of like you're in the middle of a garage. Is there any signal or not? And this that, and the other. But it's a good example of putting it in a place where it can be useful. That's outside of the norm.
Yeah, what's interesting is like the last few applications I've built has kind of really driven this point home. But throughout my career, like I mentioned with Seeker, we were building the ability to look at different patterns within voice and extract communications from medical devices. And now we moved into how do we give manufacturing machines the ability to communicate what's wrong. When I worked in the voice assistant, it gives diagnostics on the vehicle, what's going on with the vehicle. And then extrapolating that further with the use case I just mentioned at the service garages, all of these applications are really giving like machines a voice. And as AI continues to progress, it seems like we're just giving machines the ability to explain themselves and explain what's going on. So instead of having to call a service line saying, why won't my CarPlay connect in my Toyota? We give the Toyota the ability to speak back and saying, let me look into that. Let me troubleshoot my own diagnostic codes. Let me look at what's, all the data that I have from my ECU and see if I can try to figure out why CarPlay won't connect. Oh, here's an issue. It's actually not Toyota's end. It's on iOS's end. This is a known bug in iOS. Like, that kind of reasoning that allows a machine to kind of give a voice back to a customer is really interesting because it seems to be like an analogous principle with everything that I'm working on. And I see that more and more as AI progresses. We're just giving more and more voice to machines.
Yeah, I think that's a great way of thinking about it, to be honest, because even in the customer experience sort of domain, you're still doing the same thing, only the voice is being given to the business rather than a specific machine. But I think that what's very clear is that there are lots of things kind of in the world that are very difficult for the end user to understand. A washing machine, prime example. How many times my washing machine comes up with this CD50 error code? I have no idea what it means. Usually I think I've learned now it's something to do with the filter. Filter needs cleaning. But there's loads of stuff that happens with the washing machine. It just comes up with this little code. And there's so many things like that where this kind of stuff happens. Or, I had an issue with the boiler. My uncle installed this boiler. I wind him up about it all the time because he installed it, and about 2 weeks later there was an issue. So I was texting him, and I was on ChatGPT at the time trying to find out what the fault code was. And as I was just pasting in the responses from ChatGPT to my uncle, and he was going, "How the hell do you know all this?" I was like, "Well, you must have rubbed off on me." But basically, it was the case that the boiler. I can't remember exactly what the situation was now, but something was happening with the boiler. There was some code that come up, and it's like, what on earth does that mean? And as a user, you end up in the realms of just going through Google and trying to figure out what's happening. You're going through YouTube, you're trying all this kind of stuff. Whereas I think that approach of giving machines a voice is so good because everyone works with machines in some way, shape or form. Cars, boilers and washing machines, factories. There's all kinds of stuff everywhere where troubleshooting them is a nightmare. Getting a current understanding of the current status, etc. And so it's kind of like, yeah, it does seem to be an interesting area of exploration. It's interesting how most of the things you've worked on have been in that vein, isn't it? Which is it's really interesting.
Yeah, it is. I think that analogy is going to just continue, right? We'll give them, it seems like we're attaching cameras to everything. We're going to attach, all the human senses to, these very even primitive machines to give them the ability to perceive the world beyond just language. And hopefully that will facilitate even more elaborate, more detailed communication down the road. So yeah, I think we're just the first step with language, and it'll just be extrapolated to more senses in the future.
I agree. And then finally, the second question I was referring to would be that is there any sort of like results or outcomes you could share with us from those two use cases we've spoke about? You know, we spoke about the giving the voice to the machines on the factory floor, helping get people away from spending hours on end searching through manuals in physical books and stuff like that. And we've also spoke about the example of the kind of like car service and helping mechanics identify issues and stuff like that. Is there anything you can share with us in terms of like the results of this kind of work and the benefits it's brought the company?
Yeah, sure. So with on the manufacturing side, a lot of what we're seeing is when we first, I think the message with AI with our users when we were first introducing it to the manufacturing side was that AI is going to replace us, and that's not the case in any aspect at all. What we've seen is that we have a lot of users that are having their capabilities and their productivity amplified to a very high degree because they have these tools at their fingertips and they're able to get hours back in their day doing things they want to do, part of their job, instead of trying to fix things that are broken down, and the stress that comes with that, and the pressure that comes from, all the way escalated all the way up to the top of the management chain on why is the manufacturing line stopped. So I think a better acceptance and this, human AI symbiosis is occurring because people are realizing this is a tool that's going to help them. In addition, the results that we've seen as far as being able to actually like on the manufacturing line, been able to actually solve real problems with even a handful of users. So I originally thought that we would have to deploy the AI we're building to hundreds of thousands of users, and that is the goal. But I thought we'd have to deploy it to that magnitude in order to see the level of change and the level of return on investment and time savings that I originally projected. But what I'm realizing is that it's very asymmetrical. We're seeing even a handful of users getting a few hours back in their day has a lot of percolating effects throughout the rest of the manufacturing team. And that just saving a few hours here and there with only a handful of users just streamlines things so far in efficiency on the manufacturing line. And that's been really cool to see because that comes down to more effects than just the technical sides of the product, which usually is what I'm focused on. But that's just those are the most social effects of using the product, which I'm paying more attention to now. I would also argue that we've seen a lot of lift from making our ingestion really, really good. So when you're building these bots, right, and you're building this giant RAG database or any agentic mechanism, you have to focus on the data. There's got to be some data that's vectorized and embedded and put into a vector database. And I would argue that is more important by far than the LLM you're using. Because if you have bad vectors, you have bad data, you're going to get extremely bad responses, have a bad user experience, things are going to break technically. And so making sure that you're extracting data very, very well, you're understanding and contextualizing images, videos with text, and you're being able to thoroughly understand all the data in cohesion that's being extracted is extremely important to making a very positive outcome. And I've noticed that the better our ingestion gets, the more positive user reviews we get, the more adoption we get because we get better accuracy in answers. And the machines just know more because they have more accurate data. And so this concept drift we talk about is less of a problem. And we have to do continuous ingestion, right? You can't just do it once, especially because with our applications, we have a cold storage RAG database plus hot storage, which is continuously updating based on real-time manufacturing data. That hot storage is continuously evolving to some degree, right? Machines where things look differently now than they did 5 years ago, 10 years ago. And so being able to understand what those trends are, you can forecast it a bit, but what you really need is just re-ingestion, continuous learning, continuous ingestion, and that's given us quite a bit of lift as well. So to summarize all this and to answering your question, I would say the biggest lift we've gotten hasn't come from actually hundreds of thousands of users. It's actually come from a handful of users that really, not even I wouldn't say a handful, but a couple hundred users that religiously use our product and are making asymmetric changes in time savings on the manufacturing line. And by doing so, they're informing us on how we can better curate our data, how we can better analyze things, And our ingestion has significantly improved adoption as well as accuracy within all bots we build, both inside and outside of manufacturing. So I guess if anyone is moving into this LLM space and trying to build their own RAG bot or agentic mechanism, I think it's extremely underrated how important ingestion is. And I would spend a lot of time and effort looking into that because you will get a huge success rate if you just optimize your ingestion really, really well.
That's such an overlooked part as well. I think the ingestion part is almost the end part of a wider process of understanding what data you have, what shape it's in, is it any good? Is it complete? Do you have all the information you need? Is there anything missing? Do you need to do anything? Because for me, I always think about yes, the LLMs are powerful, but you want to try and maximize their use in terms of being as efficient as you can be. So if you give it sporadic data that's in loads of different formats and it talks about different concepts using different types of language, and this one's a little bit old and this one's a bit more up to date and all that you're just giving it an absolute nightmare, aren't you? Whereas if you go through the process of actually going through the data and saying, right, here's all of the stuff that we need. We know it's accurate. We know it's up to date. Maybe we've even rewritten it a little bit so it makes more sense, so we're happy with it now. And then you give that to the model and it's just like crap in, crap out, isn't it? If you give it good data that's complete, that's got everything it needs, it's all in a logical format, all in a logical structure, you're giving it less work to do, essentially. And you can focus then on matching the query to the data and summarizing and all that kind of good stuff, without giving it too much heavy lifting to do,
Yes, I fully agree. You have less work to do on the LLM end if you put more work into the ingestion end. And not only a little bit less work on the LLM end, a lot less work. Because, these are just giant search engines at the end of the day, these LLMs. And if you don't have good data from which to search, then you don't get good performance from the search engine itself. So, yeah, I fully agree with everything you're saying.
The problem is, no one wants to do that, though, do they?
No, it's a dirty job. It's not a fun process. And even you always want to keep your AI, any software system, as up to date as possible with the newest libraries, the newest models. And when a new model is released, I even notice different performance with the same setup, same prompts, same code, same ingestion, same embeddings models. And so, then things have to be recalibrated. And so, yeah, I think that's another opportunity for improvement in the future, is some way of sort of regularizing all these machine learning model or these LLMs together. But yeah, it's a never ending job to curate the data and make sure the data is always clean and always accurate and always elaborate.
Absolutely. Nice. Well, I'm sure we could have a whole hour conversation just about that, to be fair. Maybe that's part 3. Part 3, which, if we make it there, Kordel, you will get your own VUX gold cap for the hat trick. So a little incentive for you there for part 3. All right.
When we make it there, not if.
Yes.
It'll be...
Yes, all when. Right. Good point. Yeah, well spotted. When. Wicked. Well, maybe let's not leave it so long next time. What was it last time? It was 2021, September. God, that's nearly 4 years ago. That's quite a while.
Yeah. It's been, I think we've both done a lot in those 4 years. So we need to check in more.
Definitely. Let's do it. Let's not leave it 4 years next time. But Kordel, thank you so much. Such an interesting conversation. Really appreciate it. Glad that everything went well with Seeker. So glad that you're in such a great role at Toyota, doing some amazing work. Really putting AI in places where it's most useful, solving real problems. I think that's part of the problem that many businesses have, is 1, finding the problem that it can be solvable, and 2, making the right solution to solve it. And I think that obviously you've got your head screwed on and you're doing some really great work. So yeah, thanks very much for joining me, and I appreciate it. And let's not leave it 4 years next time.
Agreed. Kane, thanks for having me again, and thank you again for your audience.
Nice one. Appreciate that. And thank you all for tuning in. As always, much appreciated. We've had a little bit of a break over the summer. It's been very busy. There's been lots of holidays going on, but we're back now, and back with the weekly podcast. So thank you all for joining me, and we'll see you again on the next one. Thanks now. Bye.